Hi everyone, we're going to graph this piecewise defined function and also test for continuity at x equals 2. Excuse me. So the first thing we're going to do is test for continuity at x equals 2, and then we're going to graph so we can check it out. So here's the definition of continuity. For a function to be continuous, it has to meet all three conditions. So let's just test the first one. If it fails the first and second, if it fails the first, we don't need to continue on with the second and third and so forth. So I just need to know, this means if it's continuous at x equals 2, that means our c equals 2. That's the point they're looking at, is 2. So I'm going to check f of 2. This is condition 1. So when you check f of 2, the only place x equals 2 is here. So plug the 2 into this function here, and that gives you 4. 2 squared is 4. So yes, it does meet condition 1. F of c does exist. So now we have to check for condition 2. We have to see if the limit as x approaches c exists. So we have to check the left hand side and the right hand side. So for condition 2, I need to check if the limit as x approaches c, or c is 2, from the left. That means all numbers smaller than 2 equals the limit as x approaches 2 from the right. That means this one. That means all numbers, this should be a 2, sorry. Numbers bigger than 2. So let's plug it in. We can do this mentally. When you plug in 2 into this one, you get 2 plus 1, so this equals 3. And for this one, you plug in 2, and you get 2 times 2 minus 1, and that equals 3. So yes, condition 2 works. We have 3 equals 3. So the condition 2 works. Now, condition 3 states that the limit of, well, you can just see it right here. This limit should equal f of c. So our limit as x approaches c equals 3. But our f of c happens to be 4. So this equals 4, and 3 does not equal 4. Therefore, this function is not continuous because it does not meet condition 3. Okay? So that's how you test for continuity. Now, let's go ahead and graph this. So we have a line. These both are lines. That helps to know. We're going to start at our 2 here. And so at 2, we're going to go ahead and plug in 2. Always plug. Why do I always keep doing that? Plug in 2. So when you plug in 2 to this, even though it doesn't equal it, you're going to get 3. So you go up to 3, and that's going to be an open interval because it can't equal 2. Now I know also the y-intercept is 1, so I can go ahead and plot that. And then you just know it's a line, and it just goes on. Okay? Now, let's try this third one. At x is greater than 2, go ahead and plug in the 2. We get 2 times 2 minus 1. That's going to go back to 3. So, but it can't equal it. So that's an open circle. Then, let's just plug in, say, 3, because we have to work on the right. This is from the positive 2. So it's going to be from the right. You plug in 3, you're going to get 5. So we go 1, 2, 3, 4, 5. We know it's a line, so we're going to draw the line here. Now let's do the middle part. The middle part says at x is 2, my y is x squared. So plug in 2 and we get 4. So we're back to 2 here. And at 2, this goes to 4. So that's why the continuity didn't work here. What this is called is a jump, because it's like you're jumping up from here to there. This is called a jump discontinuity. All right? So the whole function's not continuous right there because you have this jump. All right, that's it. Thank you. Have a nice day. Bye-bye.